Hey guys, it's Mrs. Bryant. Welcome to day 2 of Laws of Exponents. Make sure you have your pink foldable so we can do part 5 and part 6, and make sure you have your ISN or some paper for notes to do some examples. Press pause until you're ready, and once you're ready, we will begin. Okay, part 5 says expand each expression, then simplify and rewrite as a single exponential expression in simplest form. To do this, we have m to the 4th power 2 times. So m to the 4th looks like this, times, and those are all multiplied, m to the 4th. So in all actuality, how many m's do we have? 1, 2, 3, 4, 5, 6, 7, 8. So our simplified expression is m to the 8th power. Now, let's do the next example. A squared how many times? Well, A squared 5 times. So A times A, there's 1 time. Times A, there's 2 times, times A times A, 3 times A times A, 4 times A times A. So, simplified would be A, and how many A's do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our answer is A to the 10th power. Next example, we have x cubed 4 times. So x times x times x, there's 1. X times x times x, there's 2. Times x times x times x, there's 3. Times x times x times x, there's 4. So our simplified expression is how many times? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, baby, I'm fine. Last example, p to the 6th power 2 times. So p times p times p times p times p times p. There's 1 time. P times p times p times p times p times p. So our simplified expression is p to the 12th power. Okay, now that we are done with the examples, go to the back page. Did you notice a pattern? Find the relationship between the exponents in the original expression and the exponent in your final simplified expression. For each of these examples, write your observation. The observation is the exponent in simplest form, the simplest, I can't spell, form, is a product, that means multiply, of the exponents. So what that means as a rule is A, M times N. You can write your own example if you want. Now go to your ISN or paper so we can do examples. We know that it's A, M times N. So 3 is your A. 2 times 4 equals 3 to the 8th power. Because they're both numbers, you need to put this in your calculator. If you put it in your calculator, it's 3 with the caret and then an 8. And you would get 6,561. Next example, x to the 5th power, y to the 8th power, and there's 3 sets of them, and we know it's a product, so 3 gets distributed to both. So our answer is x to the 15th power, y to the 24th power. And because there are variables, we cannot simplify it anymore, so this is our answer. Next example, this -3 gets distributed to both, so we're going to have g to the negative 15, h to the negative 18. Remember what we learned yesterday in class. I'm sorry, that's 27, not 18. Remember what we learned in class yesterday, that if you have negative exponents, you want them to be positive. So in order to make them positive, you have to change it to a fraction. 1 over g to the 15th, h to the 27th. Next example, 3m to the 7th into the negative 4th. This gets distributed. So 3 times 3 times 3 times 3. So that's 9 times 3 is 27. 27 times 3 is 81. M to the 28th into the negative 16. Because we have a negative exponent, we need to make it look like a fraction. So our answer is 81 m to the 28th divided by n to the 16th. Next example, this negative 5 gets distributed. So, let me plug in my tablet. So we have 2 to the negative 5, p to the negative 5, r negative 2 times negative 5, s negative 3 negative 5. So 2 to the negative 5 is going to be 32, negative 32, p to the negative 5, r to the 10, and s to the 15. Remember, when you multiply negatives together, they become positives. Because I have a negative here and a negative here, I want to make it look like a fraction. So I'm going to have r to the 10, s to the 15th over 32, p to the 5th. And that is your answer. Okay, so part 6, expand each expression, then simplify and rewrite as a single exponential expression in simplest form. What you need to know is exactly like part 5 with multiplying, except now do numerator and denominator. So our answer for the first example would be b to the 6th over d to the 8th, and that's your answer. This next example would be m to the 6th, n to the 15th, s to the 4th, t to the 24th, and then y to the 10th over z to the 20th. It's really easy. Just make sure you are paying attention to those rules. Okay, so go to the back so we can explain it. It says, do you notice a pattern? Find a relationship between the expressions. So we are going to write the exponent in simplest form of expression. Again, I can't spell, that's why I teach math. Is the product between the exponents in the numerator and denominator. So our rule would look like AM times P divided by BN times P. Again, you can write your own example if you want to. Now you need to go to your ISN, or you need to go to a sheet of paper to take notes on your examples. So we know that this 2 gets distributed to this 2, and this 2 gets distributed to this 2. It does actually, I'm sorry, it does not get distributed to this 2. We're going to leave that as a base. So our answer is 2 to the 8th divided by 3 to the 6th. Our answer is 256 divided by 759. Again, put this in the calculator. It would be 3 caret 6 or 2 caret 8. That's how you do exponents bigger than squared on a calculator. Next example, we have 2c to the 9th divided by 3d to the 11th, all raised to the power of 4. So 4 gets distributed here, so 2 to the 4th. C 36 divided by 4 to the 3rd, and then 4 to d to 11, or d to the 11th power, and you get 4 raised to the 3rd, d to the 44. 4 to the 4th power is 16, C 36 over 81, d to the 44th power. All right. Next example. T to the 8th, W to the 78 over T to the 16th and then W to the 42nd. Sorry, guys. And I messed up here. Let me do this again. T to the 48th, W to the 78 divided by T to the 18, W to the 42. And because they are a division problem, we subtract, so our answer is T to the 30, W to the 36. There's your answer. Apologize for the mistakes. Another example. Apply the exponent law from part 6 to the following example. So I have x to the 50th, y to the 25th, z to the negative 20 divided by x to the negative 10, z to the 15th. Okay, so 50 minus a negative 10 would be x to the 60th, 20 or y 25th, z negative 20 minus 15 would be negative 35. We cannot have a negative exponent, so our answer would be x to the 60th, y to the 25th over z to the 35th. So there is your answer. Last example. Apply the exponent rule and get your answer. I'm going to pause right now so I'll have time to show it to you. Okay, so what I did on this example is you need to simplify this fraction before doing anything. You can divide by 3 on both. So 3 raised to the negative 3rd power is negative 27, and 4 raised to the negative 3rd power is negative 64. So that's where the negative 27 and negative 64 came from. I then distributed the negative 3 to the exponents, and that's how I got 15, negative 18, negative 9, and 6. And because there's negatives on top and bottom, I'm going to flip-flop them. So I can bring the 64 on top to be positive,